Okay, so hello everyone, I have a problem with this angle grinder. It started to produce smoke when I was using it, and I smelled something burning, and I immediately turned it off. And I would like to emphasize that, okay? Whenever that happens, stop using it. Open it up and find out the problem, because I see some people, whenever that happens, they keep on turning it on and off and on and off with the hope that the problem is going to go away. And it's not going to go away. What you're actually doing is you are worsening the problem. For all you know, it could have just been a bad bearing or worn out carbon brush, which should have been an easy and cheap fix, but because you kept on turning it on and off and on and off, you end up with a burned armature or a burned stator or both, and you end up with no angle grinder. So in this video, I'll show you how to check this angle grinder, how to check the armature, the stator, the switch, the cord, okay, and ultimately how we can fix this. So start here. Pull this out, pull the spring that will release the tension of the carbon brush. That way, when we pull the armature out, the commutator won't snag. Let's remove the head 4 screws, pull this out, and pull the armature out. And as you can see, we can already see a obvious defect. So there's a problem. So we need to get a brand new armature, okay? Not quite, not that fast. We need to be sure, okay, so that we won't waste money. Because for all you know, there's also a problem with the stator. So even if you replace the armature, your angle grinder still won't work. Because the difficulty with something electrical is that the problem is not always obvious. So that's why we need to use a multimeter, or in my case, a clamp meter. We are only going to confine ourselves by using the continuity test and the ohms or resistance test. So continuity test, with this symbol, we are looking for continuity in the circuit. So should we do this, if there's continuity, it should beep. And if the circuit is broken, here, it won't beep, okay? So there are instances wherein we want to see continuity, and there are times wherein we don't. Now, ohms or resistance test with this symbol is how much resistance there is in the circuit that restricts the flow of current from one point to the other. So let's start checking the armature first. The armature should pass 3 tests. 1, the commutator to armature stock test. There should be no continuity. Number 2, the commutator parallel bar test. They should have equal ohms value. And number 3, the commutator bar to bar test. They also should have equal ohms value. In any event, should your armature fail any one of these tests, your armature is no good. So let's start with the commutator to armature stock test. Okay, continuity test, verify probe, verify you have contact with the armature. Okay, and you do not want this to beep once you touch any of the commutator bar, and as you can see, it is beeping. Now when that happens, that means this commutator bar together with this winding are coming into contact with the armature stock. So let's perform the same test on this new one. Okay, verify probe, verify we have contact on the armature, and it should not beep, and as you can see, it is not beeping. Now if you're wondering what this is, okay, they purposely do this to shave off metal, a little metal, to shave off a little weight in order to balance the armature. So again, no beeping and beeping, so not good. So let's move on to the commutator parallel bar test. First, let me remove this, okay? Do not lose this because we need to transfer this onto the new bearings. Let me remove the bearing as well, okay? Just so I can provide you a much more better view. Pull the bearing out. Bearing is out. Let's pull this one out too. Might as well remove this too, 10 mm, okay? Very easy. Pull this out. I'll put the nut back in, just so we won't ruin the thread. Tap that out. Remove the screw. Now we need to push this bearing out. And that came out easily enough. And we need to replace this because it has already considerable play. Okay, see that? Might as well brush this too. All clean now? Well, at least cleaner than before. So let's perform the commutator parallel bar test. Put your multimeter on the ohms test, okay? Verify probe. It should read at least 0 or 1.1, okay? Good. And check each bar and the bar parallel to it, okay? Like this. Now what we are looking for is not exactly the resistance value but consistency in value as you check each parallel bar, okay? Just like this, 3.2, 3.2, 3.2. So it's also a good idea to put a mark just so you will have a guide. So check one by one, 3.2, 3.3, 3.3. Now, I would just like to point out, okay, a difference of maybe 0.1 or 0.2 is okay, but you do not want to see a considerable drop or increase in resistance. Because if the resistance value drops, meaning there is a short between wires, and if the resistance value spikes, meaning wires are broken or burned. So continue checking 3.2, 3.3, 3.2, 3.2, 3.2, 3.3, 3.3, 3.2, 3.2, 3.2, 3.2, 3.2. So they're all consistent. Now let's move on to the bar-to-bar test. Okay, so still on the ohms or resistance test. Again, resistance value is not that important. What we are looking for is consistency. Okay, so check each bar and the bar next to it. Again, a difference of 0.1 or 0.2 is okay, but you do not want to see a considerable drop or increase in resistance value. Okay, so 0.9, 0.6, 0.8, 0.2, 0.2, 0.5. Now you see, I already marked that. There is a considerable drop in resistance value on these two bars. Like I've said, if the resistance value drops, meaning there is a short between wires, and if the resistance value spikes, meaning wires are broken or burned. So in this case, the value dropped, meaning the wires are shorted out. So conclusion, out of the 3 tests, it failed 2. Like I've said, if the armature fails even one of the 3 tests, the armature is no good. So let's move on to the stator and the rest of the angle grinder body, including the switch as well as the cord. Before we will perform a test on each, I made this diagram just for us to have a basic understanding of all the connections. Okay, so this is our stator and this is our coil windings. We have our coil input wire here and it will wind, and we have our coil output wire here connected to the carbon brush. Same with this winding, okay, your coil input wire winding, and this is your coil output wire connected to the carbon brush, and this is our commutator connected to our armature. So our coil input wire is connected to our switch, and our switch is connected to our plug. So if you see on our angle grinder, this is our coil input wire, okay, these two, this is our coil output wire connected to the carbon brush, and you have another one here, and this coil output wire is connected to the switch, like I've said, and connected to this cord and towards the plug. So let's first check the stator. So for the stator, we need to conduct at least 2 tests. The coil wire to the stator stock test, there should have no continuity, just like what we did with the armature. And number 2, the balance test. Coil input wire to coil output wire must have the same resistance value. It must be equal, okay? It must be balanced. That's why it's called the balance test. So let's check first the coil wire to stator stock test. Confirm. Continuity test. Confirm we have contact with the stator. I'll show you, okay? Just like that. One probe on the stator, and you should not have continuity on this input coil wire, this another input coil wire, and this output coil wire, and we have another output wire here. So we have no continuity, and that is good. Beep. Again, just to verify. Okay, so that is good, meaning the coil winding is not coming into contact with the stator stock as well as this coil winding. Next, the balance test, like I've said. Okay, coil input wire and coil output wire must have the same value with this. Okay, so put your multimeter on the ohm settings, input coil wire, output coil wire 1.7, and let's check this one, and it should have the same value, 1.7. so that's good, there's balance. So again, a difference of maybe 0.1 or 0.2 is okay. Okay, let's repeat that. 1.7, 1.8, 1.7. So just the same with the armature. If the resistance value drops, meaning there is short between wires, and if the resistance value spikes, meaning wires are burnt or broken. In this case, we have the same consistent value, so there is balance. Now you don't have to remove or disconnect the stator for this, okay? But just the same, I will have to disconnect and remove the stator because I don't know if you can see that there is wire stuck on the stator, most probably from the armature. Before you disconnect anything, it's good practice to take a picture of it. That way you won't get confused when you put it back together, or you can just mark it with a marker. Okay, I'll mark this here, and I will mark this here. Disconnect the coil input wire from the switch. Okay, that's one, and one here. Disconnect the coil output wire, and this one too. See? Unscrew these two, pull this out, and pull this out. Now the stator should just easily come right out, and there it is. So again, let's conduct the same test. First, the coil wires to stator stock test. Okay, confirm we have continuity, and we should not have continuity. We should not have continuity. We should not have continuity. We should not have continuity, and that is good. So again, the balance test. Check resistance, ohm settings, 1.7 and 1.8, 1.7. See, it yielded the same result. Like I've said, you actually need not remove this from the angle grinder body, but in my case, I want to clean that out. Let me pull that wire out. So let me just try to blow those wires out. So I do believe that did the trick. Conclusion, the stator passed both tests. The coil is not grounded with the stator stock, and both coil wires have the same resistance value, and there is balance. Now, just like the test we carried out on the armature, if the stator fails even one of the two tests, the stator is no good. In this case, our stator passed with flying colors. So let's move on to the switch. Let's first pull that out. Okay, much easier. And this one. Okay, pull the switch out. Let's disconnect our cord. Okay, and this one. Okay. Okay, so let's check the switch. Now, when we turn this on, what we are looking for, we do not want to see any resistance, or if there is, it should be minimal. Again, because if there is a spike in resistance, that means there is bad contact. So, put the probe here, okay, and here, and we will check the other one too, and then press this and check resistance. So let's check this one first. Put the probe here as well as here. Turn the switch on and see the resistance value. So 0.7, 0.1, that's very good. Let's try this one, okay, and then this one. Press the switch. 0.2, and that's good. 0.1, so no problem with our switch. For now, let's move on to the cord. So for the cord, just like the switch, we do not want to see any resistance. Okay, so still on the resistance settings, let's start with the white one, and 0.2, 0.1, and that's very good, meaning no resistance. See, just like that. Let's check the other one, the black one. 0.7. See, there's a little bit of resistance on the black one, and that is not good, meaning the wire is either burnt or broken. So what I intend to do is, I can see that crack there, I will cut it here, and let's check the resistance again. Let's cut the wire here. So let's check the resistance value again. Let's start with the white. See, 0.1, and that is very good. Let's check the black one, and 1.6 ohms, and that is not good, meaning there is resistance, unburned or broken strands of wire inside this cord. See, again, verify, 1.5. So I do believe this cord or this wire is what caused the armature to burn. Let's do that again. Let's check resistance, and see, it even increased to 3.5, 3.1, 2.8. So this wire, at least this black one, is not good. So if we look again on this diagram, sorry about the dirt, okay? Imagine this, the black wire, because of resistance, it receives unequal current and unequal voltage. So even if this is balanced, because there is resistance here, the coil winding for the stator does not have equal current and equal voltage because of this one. So I might as well replace this cord as well, because if I don't, even if I replace the armature with a new one, it will suffer the same fate as this old one. So I found a new cord. It's from my old finishing sander. Actually, this motor still works, but the base already broke off. So now I would just like to point out, this is much thinner, okay, but only the insulation. But as far as the wire goes, or the strand itself, this is even thicker than this one. So this is better because this is longer. Now let's perform the same resistance test on this wire. Okay, let's start with the blue. Okay, so 0.2. Let's check the other one, and 0.1. So that's good. That's actually already very good. 0.2 and 0.1. Now as for the carbon brush, it's very easy. Maybe you can also conduct a resistance test for this one too, but basically you do not want this too short, to the extent that when you put this spring on here, it's no longer able to push down on the commutator coming into contact with it. Now let me remove that. Okay, then I'll show a difference. Basically this is the old one, and this is the new one, and that is still plenty long. See that? So all in all, that is how you check your angle grinder: the armature, the stator, the carbon brush, the switch, okay, and the cord. So let me clean this up a little bit and then put everything back together, of course with the new armature as well as the new cord. The angle grinder body is now assembled, with the exception of the carbon brush. I'll install that last, and of course we have the new cord. For the armature, we need to transfer this from the old armature, okay, and then push in the new bearings. Back bearing is installed. Now let's push this in, okay. Of course, let's not forget the gear, and then the nut. Tighten that down. Okay. Of course, before we install this inside our angle grinder body, do not forget this to install on the bearing, okay. Very important, do not forget to install this back, okay. So just like that. Put the head back on. Now just a tip before you screw in the screws, okay. This is to avoid ruining the thread on that plastic. Reverse first, and then feel the screw fall into place, and then just like that. Now let's install the carbon brush. Insert that there, and then connect that there, okay. Push that in. Of course, put the spring back on to push the carbon brush towards the commutator. Same on the other side. So both carbon brushes are now installed. Now last but not least, screw that on there. Okay, so there you go. Now, let me plug this in and test this. Before I turn this on, I'm going to take a base temperature of the angle grinder body. It's 32 degrees Celsius. Then I'm going to turn this on and let it run for 5 minutes, okay? And what we are aiming for, after 5 minutes, we do not want to see a considerable increase in heat. So, it's 7:58. Gonna turn this on. And if you look at that, it's now working. Perfectly balanced, no vibration, okay? I'm gonna leave that there and gonna let that run for 5 minutes. Okay, so I think that's a little more than 5 minutes. Let's take a temperature reading again, and 34 degrees Celsius. Before it was only 32 degrees Celsius, so that is not actually considerable. So that is nice. As you can see, it works. Turn it on. Perfect balance. No vibration. See? So anyway, as you have seen, our repair work. That is how you fix your angle grinder. That is how you check your stator, your armature, your carbon brush, the switch, and the cord. Now, before I end this video, I would just like to say again, okay? I'm not a professional, I'm not an electrician or a technician, I'm only a DIYer. So should you wish to emulate what you have seen here, do so at your own risk. Okay, so I'll end this video here. I hope you found this helpful and informative. If you do, let me know in the comments below. If you're new to my channel, like, share, subscribe if you want to, only if you want to, and as always, thank you for watching.